Hi there, everybody. Meteorologist Matt Gray here. Wanted to pop in for a little late Sunday night brainstorm. It has to do with something that happened in the past week that was, well, pretty historically significant here in the inland Northwest. As some of you may heard, and I did do some considerable reporting on it earlier in the week, the climate extreme record for the state of Washington, the highest temperature ever recorded in the state of Washington, was revised to 120 degrees during that crazy heat wave back in June. So on June 29th at one of the weather stations at the Hanford site in central Washington, 120 degrees. Now, there was some stuff in that report that I didn't have time to get to in the reporting that I did last week on this event. And I wanted to highlight some things that I thought were pretty interesting. So let me bring up the report right now, and we'll go into here. All right. So first of all, strong ridge of high pressure caused all of this that lasted for days and days and days. All of these hundreds of temperature records that were broken across the Pacific Northwest. And it's really comes down to the fact of how long and how strong this ridge of high pressure, we also called it a heat dome at the time, how long and how strong that was for these all-time temperature records in dozens upon dozens upon dozens of places ended up getting broken day after day. So here is the text from the report. Had it not persisted for as long, this air mass, this warm air, would not have had time to develop such warm temperatures, and statewide records likely would not have been broken. So it wasn't just that we had a strong ridge of high pressure and we had a heat wave. We have those all the time, but it was also because it didn't move. It was stuck in one spot, and it just was unfortunately stuck over us for a long time. Let's continue reading. So this begs the question as to why this ridge was so persistent. It is believed that the persistence of this ridge could be related, at least in part, to tropical cyclone activity in the western Pacific. This is really interesting. Citing 3 research papers that were published in the last decade, one in 2013, one in 2018, and one in 2019. So this is not research we've known about forever. This is stuff that we have figured out within the last 10 years. It is known that a tropical cyclone undergoing what's called extratropical transition, so it's interacting with other weather features. That's just a short, simple way to describe it. Can and does amplify the downstream flow. In fact, it has been shown that Western Pacific tropical activity makes it 3 times more likely that a blocking ridge of high pressure will develop over the eastern Pacific or the west coast of North America. Think about that. If you could point to something happening halfway around the world and said, hey, this makes a certain weather pattern here at home 3 times more likely, that's a pretty important information. Now, I know there was some gobbledygook in there, but let me kind of bring us back to the story at hand of this crazy heat wave. And we'll get off the report here, and I'll show you what we had right before we ended up with those several days of warm temperatures that eventually led to the 29th of June, where we saw this all-time record heat around the region. So let's go back all the way to the 20th of June of 2021, and right in the middle of tropical cyclone season. So in the Northwest Pacific, these are called typhoons, and that is I forget what country the name actually is derived from, but for example, Caribbean Islanders is where the name hurricane comes from. So the hurricanes that strike the east coast of the United States. Typhoons are the same thing. It's just culturally they had a different name for them, and so that's what they still call them today. There's other parts of the world, such as Australia and in India, where they're called just cyclones. So, but they're all tropical cyclones. They all can develop that eye and that classic shape on satellite. You can see that here in this typhoon. I believe the pronunciation is called Champi. So Typhoon Champi from June 20th to the 27th. You can see its path here going through some of the Pacific islands curving away from Japan and heading out into the North Pacific. And so the back end of this track is what is most interesting for our purposes here. That is because at this point, here on the 25th through the 27th of June, it starts to interact with the weather pattern, which eventually works its way across the Pacific to us. So at the time, we're at the beginning of this heat wave, but there's also an opportunity for that heat to move on, for the weather pattern to shift, to not get locked in place. And this weather system, this typhoon, as it decayed and moved into the colder waters of the North Pacific, looks like at this point, after all the analysis is said and done, played a role in keeping that weather pattern locked in and getting us hotter day after day after day after day, so we could break these temperature records last summer. So here is how that happens. So the farther north you get, these tropical systems, they start to decay. They're just trying to dissipate, but they still have a lot of energy. Well, that energy has to go somewhere. So to skip over all the physics lessons that I struggle to remember and that hardly anybody's ever learned, that energy goes somewhere. And when these systems, when these tropical cyclones, these typhoons start interacting with the jet stream, those high-speed winds that really do control a large portion of the weather around this latitude of the world, basically that speeds up the jet stream as these weather systems, these weather features interact with each other. So what does that do? Well, that enhances every weather feature down the line across the Pacific. So it enhanced low pressure over the Aleutians, which means that the jet stream starts to curve to the north as a response to that. And what does that mean? Well, it's bringing up warm air. It's bringing up wetter air as well. If you remember, places like Portland and Seattle also had high humidity with those record high temperatures, which is a brutal combination. So down the line from that, now you have these winds pushing to the north, you've got more air pushing to the north, and thus this ridge of high pressure developed and basically was stuck there. It was already there, but now you're talking about basically adding 4 days. And they actually did this in one of these papers where they were like, hey, you end up with these really highly amplified weather patterns where the jet stream goes north and then it dips south, and it's really, really wavy. And so when you're underneath the jet, you're in a ridge and it gets really hot, and then where that low pressure is, well, that would be some much colder and stormier weather. So basically the weather becomes more extreme in that regard. And hopefully everybody's getting this. I'm running on a bit of a tangent, but this is definitely getting in the weeds. But I think hopefully it'll provide something a little interesting to you. So what happens here is that high pressure sticks around, strengthens, stronger and stronger and stronger, simply because we had a typhoon halfway across the world that interacted with the weather features that were helping to control what was going on here at home, and that added about 4 days onto this heat wave. And that was enough time for the temperature to keep going up and keep going up and keep going up, and led us, by the end of this, by June 29th, to having the hottest temperature in the history of the state of Washington. And something like, it says here in this paper, I think further down, so yeah, ultimately 116 to 128, 116 and 128 all-time highest maximum temperature records were broken or tied in Oregon and Washington, respectively. So just in Washington state, 128 all-time maximum temperature records were broken during this heat wave. It's a truly historic event, and we're going to be looking at this, the scientific community, for a long, long time. And hopefully with the first anniversary of this coming up next summer, or this coming summer, we'll be able to dive into this more and put a little bit of this research that we're looking at on TV for you guys. But that's a little preview, and I know I've been rambling on here, but hopefully you've gotten a little bit out of that and you found that interesting. And it just goes to prove again that everything is connected in the world of weather. It is incredible, it's fascinating, it's complicated, but it just goes to show that something happening all the way around the world can eventually come around the planet and affect us here at home in unexpected ways. So, thank you for joining me tonight. And if you liked this, go ahead, subscribe to the 4 News Now YouTube channel. We have all sorts of cool stuff for you and keeping you informed about what's going on in your community, cool science stuff like this, and we're even helping you figure out what to do over the weekend if you've got weekend plans. So have a good night, everybody.